These are the area formulas that will be given to you on the area reference sheet, and the two of the three, so the other one is circles, which we learned yesterday, that we will be using. For a parallelogram, the area is base times height. So across the bottom of our figure is the base, and then the height is shown with the right angle. For a triangle, the formula is 1/2 base times height. Sometimes it's written as base times height divided by 2. They really mean the same thing. Again, the base is going to be across the bottom. It will also be attached to that right angle. And then the height is in various places. So on this one, here's the height. On this triangle, the height is dropping down the middle, creating that 90-degree angle. And on this last triangle, the height is actually outside of the shape, but it is still what we use for height. So why are these formulas what they are? Basically, everything is based off of the area of a rectangle. So for area of a rectangle, we could theoretically just count every square. So 1, 2, 3, 4. And if you keep counting, you get 12, which ends up being base times height, because the base is 4 and the height is 3. Next, if we move on to looking at our parallelogram, I told you that the area formula is also base times height. And if you look, we can move this section of the parallelogram over here, and it creates a rectangle. So again, the area formula is base times height. Lastly, for our triangle, again, we can form a rectangle if we do some adjusting. So here we have a rectangle, and we could find the area of this rectangle doing base times height. For the triangle, though, we're going to divide by 2 because we only want half of the area. So that's where all the formulas come from and why they work the way they do. Next, we're just going to go through several examples. So first shape, we have a parallelogram. We're just going to do base times height. Down here I have my base. Attached to this right angle, I have my height. So we would do 5 times 4, which is 20. When you're multiplying in terms of the units, we're doing inches times inches, so that's square inches. Here on the next one, we have another parallelogram. So here's the base, and then here's the height. So base times height would be 2 times 3.5, which is 7 centimeters squared. The next example is a triangle. If you look, the entire length of the base is 7, and then the height is 4. So for our formula, we would do base times height, and we only want 1/2 of that, so I'm going to divide it by 2. So that's 28 divided by 2, so the area is 14 meters squared. And for the last example, on this one, we have a base of the triangle, which is only 2. And then our height is 3. So our formula would be base times height, and we only want 1/2 of that, so we'll divide by 2. So that's 6 divided by 2, which is 3 feet squared. So then what happens when you have other shapes that aren't on the formula list? And basically what you're going to do for those is you're going to split it into familiar shapes that you already know. So for example, if you look at this first shape, it's a rhombus, and I can split this into triangles, and I can figure out the area of the triangles. So I'm going to start by figuring out the area of just this triangle. So for area of a triangle, I need the base and the height. So I have the height, which is 6, but I do not have the base, so I need to find my base. And we can do that using Pythagorean theorem. Remember that c is always across from our right angle, so we have c squared, 6 squared plus b squared equals c squared, which is 10. So 6 squared is 36, 10 squared is 100, subtract 36 from both sides, b squared equals 64, which means that b is 8. So our base is 8. We can use that to find the area of the triangle that I've highlighted in red. So to find that area, I'm going to do the base, which is 8, times the height, which is 6, and divide by 2. So 48 divided by 2, that's 24. So the area of just this triangle is 24. It wasn't labeled, but it should have been. This is kind of the setup of a rhombus, and so I end up with 4 triangles that are each congruent, so they all have the same area. So this would be 24 here, and then 24 here for my area, and lastly the area here is also 24. And when I add those all together, I have 24 plus 24 plus 24 plus 24, so 24 times 4, which is 96. The next example is a trapezoid, and if I draw in this other height, I can split a trapezoid into 2 triangles and a rectangle. I'm going to start by finding the area of this rectangle, which I'm going to highlight in red. I can see that the base of this rectangle is 9, and the height of this rectangle is 8. So to find that area, I would do 9 times 8. So the area of the rectangle is 72. In order to find the area of the triangles, I need to figure out the base of the triangle. So this entire base of the trapezoid is 14. The top base is 9. If I subtract those 2, I get 5. So these sections here and here all together are 5. If I split that in half, each section is 2.5. Then I can use that information to figure out the area of this triangle, which is the exact same as the triangle on the left. So if I want to find the area of the triangle, I do the base, which is 2.5, times my height, which is 8, and I would divide by 2, which is 10. That's just one triangle though, and there are actually 2 of those triangles, so I would need to double this, and I get 20. To find the total area, I want to take the rectangle plus my 2 triangles, so 72 plus 20, which is 92. For the last example, I'm finding the area of this kite, and I'm going to start by focusing on this triangle only. So I notice I have a 30-degree angle, and then I'm given one of the sides. So that means I'm going to need to use my special right triangles. Across from 30 is x, the hypotenuse is 2x, and the third side's always x square root of 3. So right now I have that x equals 3, and I can use that to plug it into the other sides. I don't really need to figure out the hypotenuse because it's not the base or the height, so I'm just going to ignore it. If I plug 3 in for x, right here I'm going to get 3 square root of 3. So I'm going to erase that and label it as 3 square root of 3. So if I want to find the area of this red triangle, I'm going to do base times height. So 3 square root of 3 times 3 divided by 2. On the numerator, that gets me 9 square root of 3 divided by 2. And you can either leave it as a fraction, or you could make it 4.5 square root of 3. Now the area of the red triangle is also the same as the one right below it. So I could just double that to have the area of these red pieces. Moving on to the other side, I have a 45, 45, 90 triangle. So I need to label a little differently. So for this one, across from the right angle is x squared root of 2, and the other two sides are x. So right here I can see that x equals 3. If x equals 3, that means that this side down here is also 3. And so if I want to find the area of the blue, I'm doing base, which is 3, times height, which is 3, divided by 2. 3 times 3 is 9, divided by 2 is 4.5. And that's just the top triangle. The bottom triangle is the exact same. So if I want that area, I can just multiply this by 2. So the total area of the blue is 9. For the area of the entire kite, I'm just going to add the 2 together. So I would have 9 plus 9 square root of 3. And at this point, it's probably safe to type that into a calculator. When I type that into my calculator, I get 24.588, so we'll just round to 24.59.